Aloha, everybody. Happy Thursday. We are working out of the book for the homework today. Core Connection CPM. We're doing section 4.2.3, which is the second to the last section for chapter 4. What does that mean? Yeah, we do 4.2.4. Then we do closure problems, which is prepping for the test, right? So we got a test coming probably next Friday, probably a week from tomorrow. Okay, so now is a time where you definitely want to be sort of on high alert and paying attention to any problems that don't make sense to you, right? If they don't make sense now, that's okay. These first problems are going to be a little bit difficult. We haven't done much with these enlarging or reducing pictures or shapes with ratios. So pay attention. If something doesn't make sense, watch the video again. Go see your teacher between 2:30 and 3 during afternoon Zoom office hours and get some help. Okay? This is what mature students do. This is what students who are worried that a question like that might be on the test would do. If there was a question like that on the test, would I get it right? Okay? And if the answer is no, you don't hide in shame. It's fine to not know. Okay? You just have to add that last word, yet, right? So you can say, I don't know how to do that yet, but then make a plan to fix that problem. Okay? Go see your teacher, watch a video, watch those warm-up videos, right? Watch the homework videos, and don't just stop here with this video. Tomorrow, come back and see the second part of the video for this lesson, which will have me going through all of the answers. Okay. And the way I do it might not be the only way. You might have done it a different way, and you might have something different, and you can still be correct. Okay. But check it out and make sure. Some questions have specific answers. Some questions, like this first problem we're going to be doing, answers will vary, is what the answer book will end up saying. Okay. All right, so hopefully you're getting this, and here we go. Okay, so hold on a sec. I gotta turn that on real quick. Make sure we have some volume. I don't want to be echoing, but I want to make sure that you can hear me too. So let me pause it. Okay, sorry for that quick interruption. Here we go. John Krakauer. Who is that? Oh, you spelled his name wrong, Mr. Daniel. That's a John without an H, I think, is how John Krakauer. He's a famous author. He wrote some cool books. One book he wrote is called Into Thin Air. It was about one of those group trying to climb Mount Everest at a time when they had some terrible storms. It was just a tragic book, but it was just, oh man, it was exciting. It was tragic in one sense, and then it was amazing in others. Right? There was this guy from Texas that just would not give up. Okay. Anyway, here we are. We have a shape. You're supposed to draw a quadrilateral. I ended up drawing a rectangle. You could have drawn a parallelogram if you wanted, right? Okay. Then you could have drawn a special kind of parallelogram, which all four sides are the same. That would make it a rhombus. Okay. Another kind of parallelogram with all four sides the same length is a rhombus. But if it has right angles, it's also a square, right? But your choice. I just drew a rectangle. Make it easy because I have completely vertical height and completely horizontal sides, so it's easy for me to tell how big that is. It's 3 tall, 5 wide. Okay. Now I'm supposed to increase this by a ratio of 4 to 1. Okay. And what does that mean? That means for every 1 in my original drawing, I'm going to turn it into a 4. Now that's every 1. Okay. So this 1 should be 4. In my increased drawing. This one should be 4. This one should be 4. So how tall will this be if it's a 4, and a 4 instead of a 1, 1, 1? 4, 4, 4. That's 3 times 4, right? So once I increased this drawing, this rectangle, by a ratio of 4 to 1, I will now have it 1, 2, 3, 4. That's one of them. 1, 2, 3, 4. That's another. And 1, 2, 3, 4. How tall should it be? Well, it should be 12 now because I increased it by a ratio of 4 to 1. Every 1 here, now 4. Okay, so let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now how wide is that going to be? What do you think? Yeah, if you're thinking 5 times 4, it should be 20. You are correct, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's going to go all the way to here. Okay. So this drawing is a rectangle that now is 20 wide and 12 tall. And what we say about these two rectangles is they are proportional, okay? Because I increased the length by the same as the height. I didn't sort of make it 20 wide and only, right? Say that's 20 and only make it twice as tall, right? So 1, 2, 3, 4, 5, 6. Okay, if I only made it twice as tall, but I went ahead and made it 4 times as, then that is a different shape than that. These two shapes are the same, okay, because they are proportional. Does that make sense? It's kind of like I had the magic wand with my ratio of width to height is 5 to 3, and then I multiplied it. Every one became a 4, so I multiplied my width to height by 4 over 4, and I got 20 over 12. 20 over 12. Okay? So if the ratio of width to height is the same for, okay, I can simplify that ratio. Then that means that those shapes are proportional. Okay? Now, this is a tricky one, B, because I got my 3 to 5. But now I'm supposed to increase it, okay, by a ratio of 7 to 2. 7 to 2. That means for every 2 in my original, I'm going to go 7. Okay, so this 2, okay, is going to be now a 7. This 2 is going to be a 7, but that's a 1. What do I do with that? Well, 1 is half a 2. I got to go half a 7. What's half of 7? 3.5. So now I got 7 plus 7 is 14 plus 3.5. Kind of tricky, huh? Here I got 3 going high. Now that 2 is a 7, but this is half of a 7, so 3.5. So now my new rectangle is going to be 10.5 by 17.5, right? It's 14 plus 3.5, 17.5. So I got to go 10.5. 3, 4, 5, 6, 7, 8, 9, 10, and a half of 1. See that? I can do half of a, right? And now I got to go 17.5. So I'm going to go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.5. Not the easiest one to do, huh? This is just a hard problem. They made it hard on you. So I'm saying 17.5 here and 10.5 there. Now, I started with a rectangle that was 3 tall and 5 wide. I challenge you to do a different size rectangle and see if you can figure this out, okay? All right. That's a lot of work on one problem, right? Okay. We won't take that long on the rest, I promise. 4-71, what are we looking at? Okay, we're looking at this picture over here, and I'm going to draw that picture real quick. It's like a square. It's like 4 columns, 4 columns. Okay. Okay, and they look like this. And there's another one that's shaded in, looks like this. And then there's another one, but this next one, they're not all shaded in, right? How many of those are shaded in? Okay, it looks like 2 of those 4. Okay, so I'm just going to get a highlighter real quick and shade these in, right? I'm going to shade in all 4 of these, all 4 of these, and 2 of these. Okay, so now it says that George drew it and said, look, Helena, this is the same as 12 fifths. 2 and 2 fifths is the same as 12 fifths. So your question is, okay, is Helena the same? I mean, is Helena correct? Is it the same? 12 fifths the same as 2 and 2 fifths? Okay, if so, explain how you know that's right. And if not, explain how you know it's wrong. Okay, and then you're supposed to draw the mixed number 3 2/3. And how can you write that as a single fraction greater than 1? So that's what they're looking at, that improper fraction for 3 2/3. And then same thing with 7/4. I'm going to have you do those on your own. Okay, and I think you can. And I told you I was going to be quick on the next few. This one here, simplify that means they get the answer. This written, simplify 8 plus 2, 10, right? You're simplifying this. You're simplifying that. You're simplifying that. Now, you want help on that? Please go look at yesterday's warm-up, okay? Because if you look at yesterday's warm-up, you will see those problems done for you. 1 and 2, 1.5 plus 2 1/8, boom. 4 fifths minus 2/3 plus 1/6, boom. And I thought 5 3 fifths minus 1 4. Look at that, I did 5 2/3 minus 1 4/5. I did it wrong, and then I realized, hey, that's not the same one. I did it. Go watch that video. Watch the warm-up. You already knew that if you watched it. If you already knew that, pat yourself on the back. You have some integrity. That's what we're looking at. Okay, so 4-72 is on the warm-up. I trust you will go watch that if you haven't already. Otherwise, you just get your composition book out and you flip to yesterday's warm-up. You got it. Boom. Okay. Now, next question is, the new shipment of nails is due any day at Hannah's Hardware Haven. Okay, say that 3 times fast. And you have been asked to help label the shelves so that the nails are organized in a length from least to greatest. Okay, she's expecting nails from the following: 1 3/8, 1 7/8, 2 1/4, 7/8, 1 1/2. Use the ruler above to help Hannah order the labels on the shelves. Okay, so 4-73. I'm going to go ahead and pretend this is my thing here. Okay, so let me see. I'm sort of drawing a ruler. I don't know if you ever notice the way rulers look, right? But they're divided into eighths usually. Sometimes they even divide it even further than that. They're divided into 16ths, right? Right. And the smaller notch means a smaller amount. So that's an eighth. 2/8 is 1/4. 3/8. 4/8 is the same as 1/2. 5/8. 6/8 is the same as 3/4. 7/8. 8/8 is the same as 1/2. Okay, so I'm going to go ahead and do the same thing. Just go down. It's kind of cool with this graph paper. It's easy. 1, 2, 1, 3, and this is a half. 1 1/2. 1 5/8. 1 6/8 is 3/4. 1 7/8 and 2. Okay, 2 1/8. 2 2/8 is 1/4. 2 3/8. 2 4/8 is 2 1/2, and that's probably far enough. Are any of them bigger than 2 1/2? No, so that's probably good. All right, so draw that, and then you got to go figure out where do they go. I'm just going to write the numbers here, and I'm going to challenge you guys to put these numbers in order: 1 3/8, 1 7/8, 2 1/4, and show me on your drawing where all these show up. Okay. This is just 7/8. That's less than one hole, right? Are there any others less than one hole? Doesn't look like it, right? So some of this is going to be easy to put in order, but challenge yourself to see if you can figure out where each of those show up. Okay? Challenge for you. Challenge accepted, Mr. Daniel. I got this, right? Okay. Remember, every math problem is like a puzzle. Puzzles are fun to figure out. Cecilia wants to measure the area of her bedroom floor. Should she use square inches or square feet? Okay, and compare parts A through C as you explore this question. So I'm thinking, do I want inches or feet? Write a sentence to explain which units that she should use. Okay, so you're just going to tell me, what do you think, square inches or square feet? Answer that question and explain. If it says explain, don't skip that part. Okay, bedroom is 12 feet by 15.5 feet. What is the area of the bedroom floor? Show me how you got your answer. Okay, so the first thing I'm going to draw a picture of that. Okay, I'm going to call that 12 and that 15.5. Make a rectangle. Now, I didn't really line these up. I could have done 12 of these things and 15 and a half of the boxes. Okay, and then counted the squares if you wanted, right? But most of you know how to get the area of a shape now, and you multiply the length times the width. Okay, so 12 feet times 15.5. Okay, and that would get you the square feet. Okay, and then it says find the perimeter of her bedroom floor and show me how you got the answer. Okay, and remember on our warm-up this morning, or it was yesterday, huh? I wanted you to show me an expression for how to get the perimeter, x plus y plus x plus y, or 2x plus 2y, right? It's going to be 12 plus 15.5 plus 12 plus 15.5. That could be the expression, but then also get the answer, okay? All right, I think that's enough for you to get started. If you have trouble doing this early, hopefully you started it early like you should, then make sure you show up for the afternoon Zoom and get some help, all right? All right, have a good one, everybody. Aloha.